आज का हमारा टॉपिक है बेसिस एंड डायमेंशंस। बेसिस एंड डायमेंशंस में पहले हम पढ़ेंगे बेसिस क्या है, डायमेंशंस क्या है। बेसिस क्या है? बेसिस के लिए पहले हम लीनियरली इंडिपेंडेंट कॉन्सेप्ट को समझेंगे। अब लीनियरली इंडिपेंडेंट क्या है? लीनियरली इंडिपेंडेंट पहले ये समझेंगे। वेक्टर्स जो है वो दो तरह के होते हैं, या तो लीनियरली इंडिपेंडेंट होंगे या लीनियरली डिपेंडेंट। वेक्टर्स का क्या है? सपोज करो आपके पास कुछ भी वेक्टर्स है। सपोज आपके पास वेक्टर है v1, v2, v3 सो ऑन vn वेक्टर्स है, और ये सारे नॉन जीरो वेक्टर्स हैं। ऑल आर नॉन जीरो। अगर इनमें से एक भी जीरो होगा तो वो लीनियरली इंडिपेंडेंट होगा। आर नॉन जीरो वेक्टर्स, ये नॉन जीरो है, पहले ये कंडीशन है। और इफ एंड अल्फा 1 v1, अल्फा 2 v2, अल्फा n vn, अल्फा 3 v3 सो ऑन अल्फा n vn इज जीरो। ये हम कंडीशन पहले लेते हैं कि अल्फा 1 v1, अल्फा 2 v2, अल्फा 3 v3, अल्फा n vn इज जीरो। इसमें दो कंडीशंस आ जाएंगे। इफ ऑल अल्फाज, जितने भी अल्फाज हैं, अगर वो सारे जीरो आ जाए तो v1, v2, vn आर लीनियरली इंडिपेंडेंट। और अगर वन ऑफ अल्फाज इज नॉन जीरो, कोई एक भी नॉन जीरो आ जाए, सारे नॉन जीरो आ जाए तो भी चलेगा, लेकिन एटलीस्ट वन ऑफ द अल्फाज इज नॉन जीरो, देन v1, v2, v3 so on vn आर लीनियरली डिपेंडेंट। तो वो क्या हो जाएंगे? लीनियरली डिपेंडेंट। ये हो गए लीनियरली इंडिपेंडेंट और ये हो गया लीनियरली डिपेंडेंट। ठीक है। अब लीनियरली डिपेंडेंट जो होंगे, तो जो अल्फा मान लेते हैं हम, अल्फा 10 मान लेते हैं नॉन जीरो, मान लेते हैं कि इसमें बहुत सारे वेक्टर्स थे और अल्फा 10 नॉन जीरो है, देन v10 can be written as linear combination of v9, v11, अल्फा n v। तो जो कोएफिशिएंट नॉन जीरो होगा उसी के वेक्टर को हम लीनियर कॉम्बिनेशन ऑफ अदर वेक्टर्स लिख सकते हैं। v10 यहाँ नहीं है, v10 यहाँ है। ठीक है, वेक्टर 10 यहाँ आएगा, बाकी सारे वेक्टर्स यहाँ आएंगे। क्लियर? तो ये आपने याद रखना, अगर वो डिपेंडेंट है तो उसी वेक्टर को, जो भी कोएफिशिएंट नॉन जीरो है, उसी वेक्टर को कैन बी रिटन एज लीनियर कॉम्बिनेशन ऑफ अदर। क्लियर यहाँ तक? ठीक है। अब ये हम कैसे लिख सकते हैं? तो इसका भी एक रीजन है। देखो, हमारे पास अल्फा 1 v1, अल्फा 2 v2, अल्फा 3 v3 ऐसे बहुत सारे थे, अल्फा 9 v9, अल्फा 10 v10, अल्फा 11 v11 और अल्फा n v11। ये हमने माना था जीरो है। अब इसमें से मुझे पता है कि अल्फा 10 इज नॉन जीरो, तो मैं क्या करूंगी? अल्फा 10 को इधर रखूंगी, अल्फा 10 वालों को, बाकी सबको मैं दूसरी तरफ शिफ्ट कर दूंगी। अल्फा 9 v9, अल्फा 11 v11 एंड सो ऑन अल्फा n v11। तो ये जो अल्फा 10 नॉन जीरो है, इससे मैं डिवाइड कर सकती हूँ। तो v10 कैन बी रिटन एज अल्फा 1 अल्फा 10, अल्फा 2 अपॉन अल्फा 10, अल्फा 3 अपॉन अल्फा 10, अल्फा 9 अपॉन अल्फा 10, अल्फा 11 अपॉन अल्फा 10 एंड अल्फा n अपॉन अल्फा 10। तो आप इस तरह से जो कोएफिशिएंट नॉन जीरो होगा उसी वेक्टर को लीनियर कॉम्बिनेशन ऑफ अदर वेक्टर्स लिख सकते हैं। ठीक है। अब हम समझेंगे बेसिस क्या है। लेट B be a vector space over the field F। ठीक है। देन, ठीक है, then a subset basis of V if ये दो कंडीशन सेटिस्फाई करते हैं। जैसे V एक वेक्टर स्पेस है, S में मैंने थोड़े से वेक्टर्स ले लिए, जिस डायमेंशन का वेक्टर स्पेस है उसी डायमेंशन के वेक्टर्स आएंगे। सपोज करो मैंने 2 ले लिए, 3 ले लिए, 4 ले लिए, कुछ भी वेक्टर्स ले लिए, ठीक है। तो वो अगर दो कंडीशन को सेटिस्फाई कर दे तो वो बेसिस बन जाएगा, ठीक है। S बेसिस बन जाएगा। पहला, S इज लीनियरली इंडिपेंडेंट। S लीनियरली इंडिपेंडेंट होना चाहिए, यानी कि S में जितने भी वेक्टर्स हैं उन सबके साथ हम फर्स्ट कंडीशन लीनियरली इंडिपेंडेंट होना चाहिए। लीनियरली इंडिपेंडेंट मतलब S के जितने भी वेक्टर्स हैं उनके साथ हम अल्फाज लगाएंगे। इफ ऑल द अल्फाज आर 0 देन इट इज लीनियरली इंडिपेंडेंट, ठीक है। और सेकंड, ईच वेक्टर ऑफ V can be written as linear combination of, ठीक है, vectors in S। तो V के जितने भी वेक्टर्स होंगे that can be written as linear combination in vectors of S, ठीक है। अब सपोज इसके लिए मैं आपको एग्जांपल देती हूँ। एक सिंपल एग्जांपल है जो स्टैंडर्ड बेसिस है, ठीक है। स्टैंडर्ड बेसिस आ गए हमारे पास। अगर मैं लेती हूँ 2 डायमेंशनल वेक्टर स्पेस, ठीक है। लेट V बी अ वेक्टर स्पेस ऑफ 2 डायमेंशन, देन दो वेक्टर्स 1 0 एंड 0 1 आर बेसिस। कैसे? एक का नाम मैं रख लेती हूँ V1, सेकेंड को हम एज्यूम कर लेते हैं 0 1। क्लियर? फर्स्ट इज V1, अदर इज V2। अब वी विल पुट सम कॉन्स्टेंट्स विद देम, अल्फा 1 V1, अल्फा 2 V2 एज 0, अल्फा 1 विद 1 0 and alpha 2 with 0 1 is 0. Okay. Now we will get alpha 1 with 0 plus 0 with alpha 2 is 0. Okay. When we add this, alpha 1 plus 0 and 0 plus alpha 2 is 0. Okay. This implies alpha 1 alpha 2 is 0 and 0 can be written as 0 0. From here, we will get alpha 1 is 0 and alpha 2 is 0. Both the constants are 0. Therefore, these two vectors V1 and V2 are linearly independent vectors. Therefore, V1 and V2 are linearly independent vectors. First condition is satisfied. Okay. Each vector of V can be written as linear combination of vectors in S. Okay. I will try that. Let x, y be any vector of V. Okay. So I can write x, y as x with 1 0 and y with 0 1. Same as it is. This means x with V1 and y with V2. So x, y vector can be written as linear combination of V1 and V2. So therefore V1 and V2 are vectors of basis, या S हम कह ले, in between which has 2 elements V1 and V2 is basis of V2. Here 2 is in the suffix. This means this is 2 dimensional. If there is V3, then it is 3 dimensional. Clear? First question is, show that S has 3 elements and these are the bases of V3R. V3R means V is 3-dimensional and over the field R for real numbers. Okay. For basis, we have 2 conditions. First, S must be linearly independent, and second, each element of V3 can be written as linear combination of elements of S. Okay. So firstly, we will show that the vectors in S are linearly independent. Here are are two methods for linearly independent. ठीक है, तो easy method is determinant method. Okay, let's assume that alpha 1 with 1 0 minus 1, alpha 2 1 2 1, and alpha 3 with 0 minus 3 and 2 is 0. Okay. You will get alpha 1 0 minus alpha 1, alpha 2 2 alpha 2, alpha 2 alpha 0 minus 3 alpha 3 and 2 alpha 2 3 is 0. Then after adding I will get alpha 1 plus alpha 2 plus 0, 0 plus 2 alpha 2 minus 3 alpha 3 and minus alpha 1 plus alpha 2 plus 2 alpha 3 is 0. Okay, I can write it as in determinant form. Okay, I can write it as alpha 1 plus alpha 2 plus 0 alpha 3 is 0, 0 alpha 1 plus 2 alpha 2 minus 3 alpha 3 is 0, minus alpha 1 plus alpha 2 plus 2 alpha 3 is 0. These three vectors are 0. You have to find the value of alpha 1, alpha 2 and alpha 3. You can find it by linear equations, okay, or you can find it by determinant method. I can write it as 1 coefficients of, and alpha 1 must be in the first place, alpha 2 in the second and alpha 3 in the third place. Okay. 0, 2, minus 3, minus 1, 1 and 2, and alpha 1, alpha 2, alpha 3 is 0. Okay. I will write this as delta, determinant as delta, and I will solve the determinant. 1, 2 minus 3, 1, 2, okay, 0 minus 3, minus 1, 2, and 0 with 0, 2, minus 1, 1. You will get 4 plus 3 minus 1. So I will get 0 minus 3 and 0. 7 plus 3 is 10. That is non-zero. So two terms, product of two terms is 0. But first of them is non-zero. So then second must be 0. So then we will get alpha 1, alpha 2 and alpha 3 must be 0. If these all are zeros, then vector is S is linearly independent. The first condition is satisfied. Therefore S is linearly independent. Clear? We will show that each vector B3 can be written as linear combination of these three vectors. Okay. Okay. I will assume let x, y, z belongs to B3R. So x, y, z can be written as A. I will take A with first vector coefficient plus B with second and C with third. Okay. Clear? Now x, y, z will be equal to A 0 minus A, B twice B and B, 0 minus 3C and 2C. X, y, z. A plus B twice B minus 3C minus A plus B plus 2C. Then A plus B is equal to X, twice B minus 3C is Y, minus A plus B plus 2C is Z. Now, we will find the values of A, B, C in terms of X, Y, Z. We have to find the values of A, B and C. We don't find the values of X, Y and Z. Because X, Y, Z ko, we have to find X, Y, Z in terms of, okay? In terms of X, Y, Z is the linear combination of, in terms of A, B, C. So we have to replace A, B, C with X, Y, Z. Okay. We have to find solve these two equations. In these two equations, B is common. So A can be written as X minus B and 3C is twice B minus Y. So C is twice B minus Y upon 3. I will place the values. here b twice b minus y upon 3 is z. Okay, so minus x plus b twice b minus y upon 3 is z. Then I will get 3 minus 3x plus 6b plus twice b minus y is z. So I will get 8b is 3z plus 3x plus y. So b is 3z plus 3x plus y upon 8. I will get the value of b. Okay, we have understand what is the basis. Now, what are dimensions? Dimensions means number of elements. Number of elements in a set of bases. Bases mean how many elements are there in bases. In last example, we have done here are 3 elements. S1, S2 and S3 forms the basis. So therefore, dimension of V is 3. Clear? There are 3 elements, then dimension is 3. Clear? Number of element in a basis is known as dimension. Clear? Now first theorem is, let V be a finite dimensional vector space over the field F. Okay? And S has some elements V1, V2, Vn. These form a basis. If these form the basis, and condition is if and only if. In any theorem, if there is question in statement is if and only if, you have to prove 2 parts. First, this is the given condition, and you have to prove this other condition after if and only if. The first part is you will take this and prove this, and other part is you will take as the given part and you have to prove the other condition. So in this part we have 2 parts, as V1, V2, Vn are the bases, and I will prove that each element of V can be written as linear combination in S. And in second part, I will take as each element of V in the linear combination of uniquely written as a linear combination of S, and I will prove that the S is a basis of this is 3 part. This we have V be a vector space over the field F and S. V1, V2 and so on Vn is the basis of V. Or we have to prove that each element of V can be written as linear combination of elements in S. Okay. I will take this is the basis of V, and we have to prove that if S is a basis of V, then V1, V2 and so on Vn are linearly independent. Okay. And take any element small v from the capital V. Okay. Capital V is a vector space and small v is a vector in vector space. Okay. So if these are the bases, then this small v vector can be written as linear combination of these. Okay. So then V can be written as alpha 1 V1, alpha 2 V2. Okay. We will take simple small v. Okay. So on alpha and V. Okay. Here alpha 1, alpha 2 are constants and belongs to field F. Okay. Uniqueness, we have to prove uniqueness. We will assume that we can write this V can be written as some other constants, beta 2 V2, so on beta and V2. We will assume that we can write it as a other constants beta 1, beta 2, V2. Then alpha 1 V1, alpha 2 V2, so on alpha and Vn must be equal to beta 1 V1, beta 2 V2 and so on beta and Vn. We will take all the terms in left hand side. I will get alpha 1 minus beta 1 with V1, alpha 2 minus beta 2 with V2 and alpha n minus beta n with Vn as 0. Basis, it is a basis and V1, V2, Vn are linearly independent. Therefore, these constants must be 0. So, alpha 1 minus beta 1 must be 0, alpha 2 minus beta 2 must be 0 and so on alpha n minus beta n must be 0. So, here we get alpha 1 as beta 1, alpha 2 as beta 2 and alpha n as beta n. So, this means there is nothing difference between this and this. Okay? So, there is we can write V as uniquely as linear combination of elements of V1, V2 and Vn. So, hence V can be uniquely written as linear combination of elements of S. And this group of linear combination is known as linear span. Okay? Set of all linear combination is known as linear span. Okay? So vector space V, capital vector space V is a part of linear span of S. You can write it as sufficient part. In sufficient part, I will take this as given part. Each element of V can be written as uniquely written as linear combination in element in S, and I have to prove this S is the basis. Okay? So, इसमें we will take given है कि each element of V can be written uniquely as linear combination of elements in S. Okay? Of S. Okay. To prove S is a basis, I have to prove that S forms a basis. So, for basis, I have to prove two conditions. Firstly, the vectors in S are linearly independent, and each element of V can be written as linear combination of elements of S. Okay. So, we will take alpha 1 V1, alpha 2 V2, and so on alpha n Vn as 0. Okay. Alpha 1 V1, alpha 2 V2, and so on alpha n Vn can be written as 0 V1 plus 0 V2 and so on 0 Vn. Okay. There is uniquely, I have taken this as a uniquely written as linear combination. If this is uniquely, therefore these must be equal. So alpha 1 must be 0, alpha 2 must be 0 and alpha n must be 0. So all alphas are 0, therefore S is linearly independent. Okay. Other part, we have to prove that linearly टू प्रूफ में आ जाएगा सेकेंड पार्ट में हम इसमें we will prove that कि V can be written as each element of V can be written as linear combination in S. ठीक है? And we know that let X be any element in V, and therefore each element of V uniquely expresses linear combination of S. We have taken this, so therefore this X can be written as alpha 1 V1, alpha 2 V2 and so on, alpha and Vn. Because we have taken each element of V can be written as uniquely written as elements in S. So what is this? Then X belongs to linear span of S. So V is a part of linear span of S. Linear span of S is a part of V and V is a linear span of part of S. Okay. So from 1 and 2, so V is as written as is equal to linear span of S. Okay. So V form the S satisfied both the condition for the basis. Therefore, S is basis of V. Now, A will be X minus B, X minus 3Z plus 3X plus Y upon A. Then it will be 8X minus 3Z minus 3X minus Y upon A. This is 5X minus 3Z minus Y upon A. And C will be twice B minus Y upon 3. Okay. So 1 by 3 we will take the common and B replace as 3Z plus 3X plus Y upon 8 minus 1. So 1/3 of 6Z plus 6X plus 2Z 2Y minus 8Y upon 8. So 6Z by plus 6X minus 6Y upon 1 by 3 and 8. We will take 3 common, it will become 6 common. Z plus X minus Y upon 4. So I get the values of A, B and C in terms of X, Y and Z. So then it is, then X, Y, Z can be written as A is X minus B with 1, 0, minus 1 plus B is 3Z plus 3X plus Y upon A with 1, 2, 1 and plus Z plus X minus Y upon 4 with 0, minus 3 and 2. So each element of V can be written as linear combination of 3 vectors. So these are the bases of V. So therefore S is basis of V.